So in this case, we are going to consider a typical exam revision as we are preparing for the exams ahead of time. So that is our Free State province that we are going to look into, which was a November mock exam, and it was out of 60 marks. So we want to quickly go through the questions and see how we're supposed to attempt these typical questions. Like I said, you must revise as many question papers as possible as you are preparing for the exams. These questions, they have a tendency of repeating. All right. So also make sure that you go through the instructions, especially your answers round off to two decimal places, unless stated otherwise. So we're given the first part, which is question number one, multiple choice. So we're given question one, which is 1.1. What is the maximum number of right angles? Remember, right angles, we're talking about what? 90-degree angles. So we are given the maximum. What is the maximum in a right-angled triangle? All right. So we do understand a right-angled triangle is like this. All right, where there is a 90-degree angle. That is a right angle there. So the question is, what is the maximum number of those right angles? There is only one. It's only one that we can have. We cannot have anything greater than that. All right. So there is only one 90-degree angle. These two angles that are remaining, they are less than 90 degrees. This angle that we are talking about here will be less than 90 degrees. This angle that is here is also less than 90 degrees. There is only one which is exactly equal to 90 degrees, that right angle. So the best answer there was going to be B, where there is one. All right, moving on to 1.2, we are given use the figure below to answer the question. All right, there is a triangle, and in this triangle, you are asked what is the size of angle marked X? The angle X in the triangle that we're given, what is the size of angle X? So we do understand that as long we are given a triangle, whether it is a right angled triangle, whether it is a non-right angled triangle, whatever type that you be given, whether you're talking about an isosceles, a scalene, whatever triangle, the sum of interior angles, they do not change. They add up to 180 degrees for any type. So that is the case that we're going to simply use. That is angle X. If we are to add this one to 70 degrees, we also add to 30 degrees. We are supposed to obtain the sum of what? 180 degrees angles in a triangle. All right. So let us quickly combine what we have on the right hand side. All right. So the left hand side, so that we can solve. All right. So let's add these on the left hand side. That is X plus 70 plus 30 was going to be 100, which is equal to 180 degrees. You want to calculate for X, all right? So here, maybe some we need reason, but I already stated here that is what? Sum of angles in a triangle. All right, so that is to find X. Remember, we have an equation we need to solve, so you can simply take the 100 to the other side of the equation. It's going to be a negative. It was a positive, or simply subtract 100 both sides of your equation. That is going to give us what? X. So X is equal to 180 minus 100, which is 80 degrees. All right, so that is what we're supposed to have for X, angles that are inside a triangle. The sum is equivalent to what? 180 degrees. So the answer there was going to be on C. All right, so writing this, all right, this first part here, we could have calculated our X direct. All right, so we could have stated in the first place that our x is simply equal to, since we do understand that all the three angles were added together to give us 180 degrees. So that is the sum of 180 minus the other two angles that are remaining, the 70 and the 30 degrees. So you can simply work it that way. All right, so that was going to be x is 180 minus 100, which is simply going to give us the same answer that we obtained before. So this is how we can simply attempt our questions. We just need to understand the basics. Let us move on to 1.3, where we are given actually a triangle which is divided into other two triangles inside. All right, then they told us that in the diagram, we are given that AB is equal to DB. They are equal. AB and DB. These two, they are equal. That is the only part that we are given. AB and DB. Then the question is, what is the size of angle DCB? From this given information only, what is the size of angle DCB, the angle that is formed at point C? What is the size of this angle? All right. So how can we attempt this question? There are so many ways depending with your understanding. All right. So let us start with the easier way. From what we are given, we do understand that angles that are opposite equal sides, they are supposed to be equal. So we just have to trace the sides that are equal, these two sides. Which angles are opposite to these sides? There is angle D, there is angle 55. Angles opposite what? Equal sides. We do understand they are equal. So meaning to say by default, the angle that is formed at D, which is ADB, ADB is going to be 55 degrees. Angle D to B. From A to D to B. That angle is going to be 55 degrees, which is the one that we said it is exactly equal to the angle BAD, this one. We are talking about what? Angles that is, okay, let me just write in short. Angles opposite equal sides. All right. So if angles are opposite equal sides, they are supposed to be equal, those two angles. So meaning to say, with this understanding, we can determine the remaining angle, which is BDC on the other side of the triangle, in triangle BCD, this one. We can find this other angle that is on D. Guys, these are two triangles which are being formed, meaning to say the line ADC is a straight line from the triangle ABC. AC is a straight line. So meaning to say the angle that is formed at D, because at D there are two angles. We must have what? 180 degrees. We know that they are supplementary, these two angles. So the remaining angle that is at D, which is BDC, we can calculate that one. Angle BDC is going to be 180 degrees minus what? 55 degrees, angles on a straight line. So that is what we can have in this case. So these are angles on a straight line. All right. So that was going to give us the difference of 125 degrees. So that is 125 degrees that we have. Now, let us focus with triangle BDC only. All right. We want to focus with this triangle BDC only, this one. All right. So this is what we have. And focusing with this triangle, we are going to notice that we have got two angles inside of this triangle that we are given. The one that we calculated, the 125, and the 28 degrees that we were already given. So the question is, how can we determine the remaining third angle, which is at C? The third angle at C. Remember, angles in a triangle, guys. So in triangle BDC, we can now determine the angle that we want, which is this angle C, which they gave us as what? DCB. The angle DCB can be calculated. DCB. That is the only angle that is remaining of the three angles that we know in a triangle. We are given two, we do not know this one, C. So you can simply subtract from what? 180 degrees, just like what we had on this question. When we were given two angles, we want to calculate the third one. We can simply subtract the two angles that we are given from what? From 180 degrees. So that was the concept here. So we're going to subtract the 28 degrees inside the triangle, the 125 degrees inside of that triangle BDC. All right, so that was going to give us 180 degrees minus 153. Then subtracting these two, we're going to obtain 27 degrees, meaning to say the best answer was going to be A, where there is what? There is 27. So that is how you can answer this one. There are so many ways. So many ways of calculating such. You just need to make sure you have a reason for each stage that we have. There is a reason. So here we're talking about what? Angles in a triangle. Sum of angles in a triangle. We know that they add up to 180 degrees. All right. On question 1.4, use the fig below to answer the question. So there is a fig, which is our diagram, a right-angled triangle. So we're asked to answer the question, use the Pythagoras theorem. You're already told there. You are being told what to use. Use the Pythagoras theorem. What is the value of what? Of m. So m is the hypotenuse, the one that faces or that is opposite to what? To the 90-degree angle. We do understand that is the longest side, our hypotenuse. So hypotenuse squared given a right-angled triangle that we are used to, let's say we are given a right-angled triangle. This is A, this is B, this is C. The hypotenuse, which is C squared, is equal to the square of what? The sum of square of the shorter sides, A and B. C squared, the hypotenuse. So simply hypotenuse squared. So what represents our hypotenuse is m. So therefore, m squared is equal to what? The sum of square of these two shorter sides that we are having, the 2 and the 4. So that's 2 squared plus 4 squared. All right, so let's simplify. M squared is equal to 2 squared. That's 2 times 2, which is 4. 4 squared, that's going to be 16. 4 times 4. All right, so having this, we are going to add these two. That's m squared is equal to 4 plus 16, which is what? Which is 20. Remember, when solving equations, x squared is equal to 4, you have to introduce the square root to get rid of what? The square. It is the same thing whether it is m squared, whether it is p squared, it is q squared. As long there is a square. Introduce what? The square root. And we are talking about a side. The square root of any number we do understand is plus or minus. Square root of 4 plus or minus 2. Square root of 9 plus or minus 3. But when we are given a side, there's no plus or minus. It's just a positive, all right? The length or distance, it's only positive. You write it as a positive what? As a positive value. So therefore, m is equal to, can we simplify the square root of 20? We do not know that one. So we're just going to write it as what? Square root of 20. So that's B representing what? Square root of 20 units. So let's say they gave us answers in decimal form. You're going to simplify that square root of 20. What is the square root of 20? that is 4,47. We do not have anything that is written as a decimal. They just gave us the exact simplest format that we can have for our level. All right. So sometimes it depends with the question. This is multiple choice. Remember, you have to look into the answers. How are they given also? So the best answer there was going to be what? B, the square root of 20. Let us look into another question, 1.5. In the diagram that we are given below, we are given that line N, this line N that we are given, and M, and this line N and M are cut by transversal line P and Q. All right. So they are saying it is actually, these are transversal lines because we've got two lines there. The line P, this one, it is a transversal line. The line Q, it is also a transversal line. Remember, what is a transversal line? It is a line which cut two lines that are parallel, or maybe any number of parallel lines. So in actual sense, being told that line P and line Q, they are transversal lines, these ones, it simply tells us that line N and line M, they are parallel. We can only have a transversal line from what? Two lines which are parallel. All right. So it is an automatic say that we are given there to say that line N and this line M that we are seeing, they are parallel to each other. So if they are parallel to each other, what value of x would make lines N and M parallel? What would be the value of x for these lines to be parallel? Because already we're told there's a transverse there. So simply find the value of x. Okay, what can we do? We do understand that if these two lines, besides being transversal lines, guys, as long two lines cut each other or crosses each other like this, vertically opposite angles are formed. We know that. And they are equal. So if we check properly, there are vertically opposite angles here. The 80-degree to this one. So we can find this other angle here to be what? 80 degrees. Vertically opposite angles. Now to find x, I want us to see something which is also part of our parallel lines. We can see that we are forming a C here. We are forming the C, which is from our co-interior angles. But if we look into this, we have got two angles that are to be combined together inside. The 30-degree and the 80 degrees together. So if we add 30 and 80 together, we combine this to give us a single angle. It is going to be 110 degrees. If we add 30 and 80, that's 110 degrees. Okay, so thus we can find this angle x. Remember, from those angles that give us a C, co-interior angles, we say they are supplementary, whether it is giving us a hue like this, whether it is like this, whether it is like this. They add up to 180 degrees. So meaning to say the angle x added to the 110, the combination of these two angles together, which is the 110 degrees, we must obtain 180 degrees. We say these are co-interior angles, just like that. So meaning to say we can have the value of x. Subtract the 110 degrees, both sides. That was going to give us 70 degrees, 110 from 180. All right, so that's 70 degrees that we are having. So the best answer there was going to be on C, where there is 70 degrees. So that is how we can simply play around with these questions. All right, so let's consider question 1.6. Which quadrilateral has diagonals that always bisect? All right, they always bisect its angles and also bisect each other. All right? So there is a rhombus, a rectangle, a parallelogram, and a isosceles trapezoid. So it's all about the properties that we have, but the best answer there was going to be a rhombus. Remember, I explained the properties of these shapes. If you check on a rhombus, we said it is just like a parallelogram, its properties, all right? And when we check it, all sides are equally, remember? And when we talk about the diagonals, if a diagonal is being drawn, this one, and another one is being drawn like this, these diagonals, they bisect each other. The diagonals, they bisect each other. And they do not just bisect each other, but they do so at 90 degrees. But they do bisect each other. They bisect each other is there. They bisect each other at 90 degrees. It's a special angle that we're talking about to say at 90 degrees, but the word bisect is that they bisect each other at 90 degrees. Then another concept, if we check on those properties, we talked about the angles that they do bisect these ones. They do bisect these angles. This angle is divided into two. Same with this one, divided into two. If we check this other side, this diagonal is going to bisect this angle into two. This angle into two. So that was the best that can give us the property that we are given there. That was going to be a rhombus. So go through, guys, the properties of each and every shape as we illustrated on the introduction videos. All right, 1.7, we are given in this fig below, triangle ABC is congruent to. So is congruent. Exactly the same. Congruent means exactly the same. So in terms of congruence, guys, exactly the same. In terms of angles, we can talk about angles, exactly the same. All right, so let's talk about these properties. If triangle ABC is congruent to triangle XYZ, as we are given on our information there, which statement must be true then? Which statement is true? We do understand here, guys, from angles, the angle A and angle X, they are supposed to be the same. Exactly be the same, angle A to angle X. They're supposed to be the same. Angle B and angle Y, they're supposed to be the same. For congruence, it's exactly the same. Angle C and angle Z, we can take it from that given, from the given triangles as we are told. These angles will be equal. That is the property in terms of angles. Another property from congruent figures, guys, are the sides. The way they are given in that sequence, if you take this sequence A, B, like that, it's a side, this one. All right, so these are angles. These are sides. Side AB is exactly equal to side XY. That's what we know. We move on B to C. Side BC must be exactly equal to YZ, correspondingly the way that is given. So if we take from A to C, side A to C, it must be exactly the same as X to Z. That's how we take these congruent figures. They're exactly the same in that way. So which one is given here as a property that we can say, or as a statement that we can say is true? They are saying angle A is equal to angle Y. All right, that's wrong because angle A is equal to angle X. So A is wrong. B, angle A is equal to angle X. We have it on a property of what? Congruent figures. So answer B is correct. AC is equal to YZ. AC is equal to XZ. So this is wrong. This is wrong. BC is equal to XZ. BC must be equal to YZ, not XZ. So this is also wrong. So the best answer there was going to be B. All right. You check on the triangle that you're given. There is a property that you need to know. There are properties that you need to know. Congruent figures, they must satisfy this concept that I have illustrated here. All right, so let's move on to 1.8. In the diagram, we are given triangle CAB, angle A 70 degrees, angle B 50 degrees, and BC is extended through D. BC is extended to D or through D. Okay, then from that, what is the size of angle ACD? AC to D, this exterior angle that is formed outside of the triangle. What is the size of this? We do understand from the properties of triangle, I explained, guys, that the exterior angle is always equivalent to the what? Sum of opposite. Sum of two opposite interior. Two opposite what? Interior angles. Meaning to say the exterior angle that we want, which is ACD, must be equal to the sum of the two opposite interior. Opposite. This one and this one. Those are the opposite interior. The 70 and the 50 degrees. So adding these two together, that was going to give us 120 degrees, which is the best answer there. Was going to be what? Was going to be B on the answers that are being provided. All right, so let us check another question, which is 1.9. In this diagram that we are given below, we are told that AC, this line AC bisects BAD. So BAD is divided into two equal parts. This angle and this angle will be exactly the same. Angle BAC will be equal to CAD from what we are given. Angle BAC is equal to CAD. Those two angles are exactly the same. All right, angle B is equal to angle D. We are told, this one we are told, it's not something that we can see from the diagram. They told us. We never assumed this. They told us. Angle B is equal to angle D. Now, which method could be used to prove that triangle ABC is congruent to, we talked about this, to ADC? They gave us the case of congruence. They want us to determine the case of congruence. What is it that made us to say these two, they are congruent? Is it because of side? Are they the sides that we are given? We are not told about the sides. The only side that we know that is the same is AC. It's a common one. So let us see what we are given, which is the same. Angle B and angle D, they told us angle B is equal to angle D. We are given that. Then we saw that the angle that is at A, this one, the angle at A in this triangle, and the angle at A, this one, in the other triangle, are exactly the same from this part. Then there is AC, the line AC, this one, which is common. It is the same thing for both triangles. It's a common line. So this can be our case of congruence. What exactly we saw that this one is exactly the same. We saw the angle, and the side. So it's angle, side. Do we have that? Angle, side. It's there on what? On D. So the best answer to illustrate this was going to be D, angle, side. They are asking you for the case of congruence. What is the case of congruence? What is it that you can conclude to say, truly these two figures, they are congruent to each other? On question number 1.10, what is the perimeter of a square whose diagonal is 3 square root of 2? Whose diagonal? We are given the diagonal of a square. This diagonal, all right, this diagonal like this. This is what we are given. A diagonal. The length of the diagonal there is one that we are given, 3 square root of 2, meaning to say is the same as that one, 3 square root of 2. Then they want you to calculate to say what is the area. What is going to be the area? All right. How can we answer this type of a question? So many ways. But let's say I want to find from what we know from a square. To say in a square, area is equal to side squared. So meaning to say we must have a side. So in this case, we do not have the side, but let's take it as a triangle, this one. Let's take this one. Let's just take one side, or from that diagonal, we produce a triangle from this diagonal like this. We take it that way, from that diagonal like this. As we can see, it will be a triangle that you're going to formulate like this one. So the diagonal, this one is 3 square root of 2. Remember, in a square, all sides are equal. So this is S, this is S, this is S, this is S. They're equal. This side, this is S, this is S. So we can find that S because we do understand we are in a right angle triangle. Why? In a square, the angles are each 90 degrees. So meaning to say this is 90 degrees. So we can find S. From our Pythagoras theorem, we do understand hypotenuse squared 3 square root of 2 squared is equal to what? The sum of the shorter side, the square of the sum of what? Shorter sides. So that's S squared plus S squared. So we can find this. 3 square root of 2, guys, squared. Use your calculator, guys. Your calculators are there. Open your bracket. 3 square root of 2, like this. Move aside. Close the bracket, then square it. The answer is what? 18. So 18 is equal to S squared plus S squared. This is 1 plus 1. 1 plus 1, that's what? 2. So we've got 2S squared. Divide by 2 as we've got a product here. So S squared is equal to 2 into 18. That's 9, on 18 divided by 2. That's 9. So to find S, we're simply gonna what? Introduce the square root. But as you can see, we already have, we said area of a square. All right. The area of a square in that case. Here they wanted what? Is it area or perimeter? All right. So sorry, what is the perimeter? All right, perimeter, not area. I thought it's area. But if it was area, we are already having it here. S squared, that's area. So the area is 9. But in this case, they want perimeter. So let's find the square root. Square root, square root. So S is equal to the square root of 9, which is 3. So if the side of each part that we are given is 3. If each side is 3 units, this is 3, this is 3, this is 3, this is 3. So guys, what is the perimeter? Because we have the side. Perimeter of a square, that's 4S. 4 times one side. Or you add all the 4 sides. Or just simply multiply by 4. 4 times each side. Each side is what? 3 units. So times 3, that's going to be 12. So our perimeter is what? Is 12 units. They wanted perimeter, not area. So perimeter, that's 12 units, which is on what? Which is on B. So questions can be like that. Questions can be like that, where you are given to find such. You just have to understand the question. All right, you just have to understand the question of what you're given. There is another way that we could have answered. Okay, so this one is another way. When you are given diagonals, you can work with the area. Besides what we had to calculate from that Pythagoras concept, we can use diagonals. It follows that where we have got diagonals, in that case of a square, rectangle, and so forth, we can use the area as half product of diagonals. Half product of what? Diagonals. That's another way to calculate area. Half product of diagonals. So that is half of the product of the diagonals. The product, each diagonal, the diagonal is 3 square root of 2 times another diagonal 3 square root of 2. Half product of diagonals. You multiply the diagonals, then your answer you multiply by half. So 3 square root of 2 times 3 square root of 2, that is the same thing that we calculated here when you said 3 square root of 2 squared. We got what? 18. So it's half times 18. What is half of 18? Which is 9. So we have the area 9 square units. So if you have the area, how do you find the side? Because you understand that area is side squared. So you simply say side squared is equal to 9. So introduce what? The square root. So s is equal to 3. Therefore, perimeter is 4 times side, which is 4 times what? Times 3, which is 12 units. All right, so that is 12 units in that case. All right, this is area square units. This is our perimeter, 12 units. So many ways that we could have answered this question. It's another way. In case maybe you did not understand the first one, you can use this one. You find the area since you are given the what? The diagonals. Area is half product of diagonals. You find area. You know that area means what? Side squared on a square. So from that side squared, you calculate the length of each side. After that, you can calculate your perimeter at the end. So you just have to figure out, guys. That's why I say do revise as many questions as possible. You see that most of these questions are just a repetition. They do repeat. All right. So let's check another part of our questions. Question number 2. We are given here, name the relationship between angles in the diagrams below. Is it complementary? Is it supplementary, vertical, or adjacent? All right, there we have got a straight line. Then there are two angles on a straight line. So two angles that are found on a straight line, we can say they are supplementary angles. So remember, supplementary, these are two angles which add up to 180 degrees. So these are supplementary angles. Also, these angles, they are adjacent to each other. So we could have even used adjacent two angles which are sitting next to each other. So we can also use that one. But the special case was because of a straight line. All right. Then 2.2, we have got a right angle that is indicated here in red, this one. So that's a 90 degree that we are given there. We do understand that angles on a straight line add up to 180, but the moment we remove 90 degrees, it means we are also remaining with another 90 degrees. 90 plus 90 to give us what? 180 degrees. So it simply tells us that the relationship between A and B, the issue is the relationship between A and B, not this one of the 90 degrees that is outside. These two angles together combined, only A and B. What is it that they are related to? They are giving us a right angle which is 90 degrees. There are two angles that we have adding up to 90 degrees. So they are what? Complementary angles. So we've got complementary angles. So that is the best answer there. Two angles which add up to 90 degrees. So these are complementary angles. We are talking about two angles which add up to 90 degrees. All right. So A plus B is equal to 90 degrees. That's what we are simply saying here. Angle A plus angle B is equal to 90 degrees. I mean, on this one, for supplementary, I'm simply saying angle A plus angle B is equal to what? 180 degrees. All right. Let's move on to another part, 2.3, where we are given this. Two lines which crosses each other, that is vertically opposite angles, are formed where angle A will be equal to angle B. So these are vertical angles, vertically opposite angles. So according to what we are given, they just gave us as what? Vertical. So it's just vertical what? Vertical angles. All right. That is what we have there. Then the other part, these two, this one is not a straight line. Take note, guys. This one is not a straight line. It is different from the first one, 2.1. We had a straight line on A and B. This one was direct straight line that we are seeing. This one's a straight line. There are no joints to say it's from this point, then it changed like this. So the best way was to say they are supplementary because they're talking about two angles adding up to 180. But these two, they are not supplementary. Also, they are not giving us any special case of a 90-degree angle. This one is not a 90-degree angle. So what can we say about these two angles? There we can just say these two angles, they are adjacent to each other. Like I said before, it could have been used on A and B because they are also adjacent to each other. But there's a special one, supplementary angles. The same case with this one, A and B, they are adjacent to each other, but there's a special case of being what? Complementary. So on the last one, the best answer there was supposed to be adjacent. There is no special property that these two angles, they add up to. We cannot say they add up to 180. It's wrong if we say so. We cannot say they add up to 90 degrees. It's wrong if we say so. They are just adjacent to each other. All right? They are just what? Adjacent to each other. These are just adjacent angles sitting next to each other. No special case that we can talk about. No special case that we can relate from our properties of angles. All right, moving on to question number 3, where we are being asked to answer based on the diagram below. We are supposed to focus on this diagram that we are given to answer the question which follows, which is determine with reasons. All right, it was this one, or the question is just down here. All right, prove that. That is our question here. Prove that line D is parallel to line E. Line D is parallel. Line D, this is our line D, and this is our line E. Prove that they are parallel. If these two lines are parallel, we must have anything that is to do with our properties of parallel. Is it from our F angles, the corresponding angles? Is it about alternate angles? Is it about co-interior angles? There is supposed to be something which we can relate to. As long as there's something from parallel lines, therefore the two lines, they are parallel. So what is it that we can use? All right. I want us to focus on this part of B here. There's something that we can use there. We do understand that angles on a straight line, they add up to 180 degrees. So if we focus at point D, at point B, at B, we can see that the angle that is remaining, which we can, let's just call it B, because if we put it that way to say it B, to be like at a certain point, but let's just focus on finding that as B. Let's just say this is our B, this one. That B that we see here, from 180, because we're talking about two angles that we have on a straight line. So you can say the angle that is at B is 180 degrees minus 60 degrees, which is what? 120 degrees. Here we're talking about what? Angles on a straight line. You must actually give reasons there. Angles on a straight line. So if the angle is that is at B here is 120 degrees, is there anything that we can relate from what is happening on this line E and line D so far? Yes, there is something. Which is what? Which is the F angles, the corresponding here. If we check what we related on our F angles, the B, which is 120 here, and this one on line D, on our line D, there's also 120. They are exactly the same, these two. Guys, these two angles cannot be the same by any chance. It cannot happen like that. It can only happen that these two angles, they are the same if truly the two lines are parallel. There is no way that this will be 120 and this will be 120. There is no way. There is no way. We have 120 degrees from our line E, exactly the same as 120 degrees on line D, which maybe we can just call this one angle C. That is from our corresponding angles, F angles. alternate angles. Sorry, corresponding, not alternate, but what? Corresponding angles here. Corresponding angles. So automatically, these two lines, they are parallel. So therefore, line E is parallel to what? E is parallel to D. These two lines, they are parallel to each other automatically because of what? Corresponding angles, which makes these two to be the same. So you must figure out which property. Maybe it was going to be from alternate angles, as long you can prove it to say this angle and this angle, they are the same. As long you can prove that, automatically tells us we are talking about what? Alternate angles. We could have used that one, because if we say 180 120, this one from 180, we are gonna have 60 degrees. Look what is happening. If we check here properly, we are forming what? Alternate angles, z like this. We can also use it, or find this one angle at C, it's 120. We can talk of these alternate angles like this, 120 at B and 120 at C. As long you can prove any one property of what? Parallel lines, you can conclude to say that they are truly parallel to each other, as long you can prove one. All right, so let's consider another part, which is 3.2. On 3.2, we are given to determine with reasons the values of A and B in the following figures. Thus, all right, yes, 3.21, exactly direct, guys. Angle A is equal to 40 degrees. Why? Vertically opposite angles there. So we are talking about what? Vertically opposite angles, they are equal. Then to find angle B, angles on a straight line, either from these 40 degrees or from these 40 degrees, angles on a straight line. So B is equal to 180 minus 40 degrees, which is 140 degrees. That's angles on a straight line. All right, angles on a straight line. All right, 3.22. Also, we talked about this one. I think it was our first part of our questions, this part. These two being equal, and I said angles opposite these equal sides are supposed to be equal. So angle B must be equal to 62 degrees. As we have got that one, angle B is equal to 62 degrees. These are angles opposite, equal what? Equal sides. All right, then the angle A, which is the remaining one, is angles in a triangle. We're going to simply remove the 62 and the 62 from 180 degrees. Remove 62 degrees plus 62 degrees. These are angles in a triangle, right? Angles, sum of angles in a triangle. Sum of angles in a triangle. All right, so A was going to be 180 minus the sum of these two. That was going to be 56 degrees. Let me just write the answer here, guys. All right, okay, no problem. So that is 180 minus these two. 62 plus 62, that is gonna be 62 times 2, which is 124. So that is 180 minus 124 degrees. All right, so that is it. And on 3.23, there is this shape. All right, let's look into it. Two lines are given that are parallel. So meaning to say we've got alternate angles. We are forming a Z here, a Z. Alternate angles. Angle A and the 40 degrees are supposed to be exactly the same. So A is equal to 40 degrees. These are alternate angles. As line LO is parallel to what? Line LO is parallel to MN. All right. Then we can find angle B, since there is a right angle at N. Remember, right angle simply means what? 90 degrees. So we are given two angles. We need to find the third angle in a triangle. That's 180 degrees minus the sum of the two angles that we are given inside the triangle. Sum of angles in a triangle. So that's it. That's it. So that was going to give us 90 plus 40, which is 130. From 180, that's 50 degrees. So we're going to have 50 degrees at the end. So that is our angle B, which is 50 degrees. Or we could have answered this one, angle B. We could have just said the angle that is L O N, L O N, this one is 90 degrees. So if it is 90 degrees, therefore the angle B is simply going to be 90 degrees minus 40 degrees, as they are complementary angles. So 90 minus 40 was going to give us 50 degrees. Still, guys, we have got the same answer. There are so many ways that we can use to attempt these typical questions that we are given. We just need to revise as much questions as you can. All right, so let's consider 3.24. What can we do to determine angle A? There are three unknown angles. Angle A, we do not know this one, we do not know this, we do not know this, but they are inside what? A triangle which add up to 180 degrees. So if I take this A, add to this one, 4A, add to what? 2A plus 40 degrees, I'm supposed to obtain 180 degrees angles in a triangle. So that's it. We talked about this, guys. Sum of angles in a triangle, which is 108. So let us solve for A. We have an equation, guys, isn't it? That's an equation that we have formed there. Solve for A. So that's 1 plus 4. So we're going to have 1 plus 4, which is 5, plus 2, which is going to give us 7A. All right, then there is a 40 degrees which is remaining here. So plus 40 degrees is equal to 180. 7A is equal to what? We can take the 40 to the other side, or simply what? Subtract the 40 degrees both sides. So that was going to be 180 minus 40, which is 140. So to determine the value of A, you can simply divide by what? By A. So 7 into this, or 140 divided by 7 was going to give us what? 20 degrees, just like that. So that is it. Angles in a triangle concept. You can use that concept. Angles in a triangle, they add up to 180. So using that, you form an equation, you solve it. On question number 4, we have got a question where we are being asked to determine the area of triangle ABC and also the triangle CDE. All right, so there are two triangles ABC. This one. So what is it that we can use? Area, half base times perpendicular height. But the question is, we do not have the perpendicular height. Remember, it is supposed to be at 90 degrees. Two lines which do meet at 90 degrees. This being our base, this will be our perpendicular height. There we are given the hypotenuse, the one that is not even needed. So the question is, what can we do? What can we do? Okay, no problem. We can simply find that height, the perpendicular height, as we've got two sides. Remember our Pythagoras theorem, all right? So let's start with the triangle ABC. So for triangle ABC, we're going to calculate AB first using Pythagoras, or from Pythagoras theorem. Calculate what? We're going to calculate AB first, the length of AB. Remember, hypotenuse squared, our hypotenuse, which is 25, hypotenuse squared is equal to A squared plus B squared, where our hypotenuse is 25. So 25 squared is equal to the sum of squares of the shorter sides, which is the AB, to be calculated, and the other side BC, which is given as what? As 7. So in actual sense, we could have written some, they want to write it this way: AC, our hypotenuse AC is equal to AB squared plus what? BC squared. All right, let me do it that way. No problem. So let's simplify. 25 squared, we're just going to square 25 times 25, 625 is equal to AB squared plus 7 squared, which is 49. Take the 49 the other side, or simply subtract 49 both sides of your equation. You're going to get AB squared equal to 625 minus 49, which is what? 576. To find AB, introduce the square root both sides of your equation. So therefore, your AB was going to be 24 units, as we are not given centimeters or what. This is what? 24 units. Therefore, the area can be calculated having what? The base and the perpendicular height. The two which are at 90 degrees. So therefore, area in triangle ABC, half base times what? Perpendicular height. Half times the base, which is 7. You have it. Times the perpendicular height going up at 90 degrees. We've got what? 24. So that is how we can play around with this. So you can even use your calculator, or you can simply divide 2 into 24. 24 divided by 2, that's 12. Then 12 times 7 was going to give us 84. So that's 84 square units. We are talking about area measured in what? In square units. So that is for triangle ABC with the same concept, same understanding. You can do the same thing for the triangle CDE that is remaining here. You can do the same thing for triangle CDE, as we do not have what? We do not have the perpendicular height. So, but our Pythagoras is there. Hypotenuse squared, which is CE squared, is equal to the sum of what? Shorter sides, which is the DE squared, plus the other shorter side, which is CD squared. So what is our CE? That is 25. So 25 squared is equal to, we need to find DE. So in this case, we must find DE first. All right, so let us substitute what we are given from C to D. That is 20. So let's simplify 25 squared. Again, we simplify this. Before it was 625 equal to DE squared. There is a squared. 20 squared, that is 400. Subtract 400 both sides, or simply take it to the other side. That was going to give us DE squared equal to 225. All right, so that's 225. So introducing the square root, just like the previous case, you're going to determine the length of DE, which is 15 units. Let's just say 15 units, as we are not given. These are centimeters. These are what? So this is 15. So what will be the area now? We have applied the Pythagoras in order for us to determine the third side. So that is why you see this question had a lot of marks, 7 marks. Now that we have got the base and the perpendicular height, let us determine the area of what? Triangle CDE. Half of base times what? Perpendicular height. That is half of the base, which is 20, times our perpendicular height, which is 15. You can use your calculator, or half of 20, that's 10. 10 times 15 is going to give us 150 square units. This is area. So that is how we can have these guys. Just try to figure out, revise as many questions as you can. You understand that it is just a repetition. They do repeat similar questions like these ones. All right. On 4.2, they said find the length of the diagonal of the given rectangle. 3 marks. The length of the diagonal. All right, a rectangle, we do understand there's a 90 degrees. So definitely I have got a right angle triangle. Pythagoras theorem can be used, whereby the diagonal represents what? Our hypotenuse. So if that is the case, therefore C squared is equal to same units given, so there's no problem there. That's 21 squared plus 28 squared. So C squared is going to be, guys, you're going to simplify each or just combine it once. But 21 squared is 441. 28 squared is 784. Then adding these two, I was going to get something like 1,225. then introduce the square root both sides, just like the previous questions we had. That was going to give us 35 millimeters, as we have got the other units given before in what? In millimeters. So that was a little bit direct question of all the questions that we had in this question paper, guys. Question 4.2 was a little bit direct. All right. Anyways, I don't know, guys, on your side. Let's see on question 4.3. Let x in the fig below. All right. Let x in the fig below is a perpendicular to. This statement does not make sense. They just said let x be the perpendicular height to this. All right. But anyways, it makes sense the way that we just understand. They are saying this one is at 90 degrees. And also, this question, they did not fully give the information. We had to make assumptions there which are not necessary, but you are supposed to be given full information. The perpendicular there was not a direct thing. It was, they were supposed to give us as perpendicular bisector. It was a missing part there. A perpendicular bisector, meaning to say it is not only at 90 degrees, but it does divide the line that you are given into two equal parts. It is not just at 90 degrees. So they're supposed to give full information, not just you are in exam. You make assumptions in exam. Exam is not for assumptions, guys. It is to answer the question. But when you face a situation like this, there is no way you're under exam condition. You are not at Maison African motives, so you must answer questions. All right. Anyways, the question was find the length of the unknown side x to two decimal places. What will be our unknown side if we know that it is a perpendicular bisector? We know it is going to divide the 6 centimeters into 2. 6 divided by 2, which is 3 centimeters. So there is a 3 centimeter, there is a 3 centimeter here. So taking this triangle, one triangle that we are given, because these two triangles will be identical, exactly the same. So instead of you having confusion that you are working with this other triangle, you just work with one triangle, right? So working with this triangle, you can see that there is 75 millimeters. You can convert to centimeters. You can convert the 3 centimeters to millimeters. It is in your hands. So let us convert this one to centimeters. 1 centimeter is equivalent to 10 millimeters. What about 75 millimeters? It's gonna be more. So that's a direct proportion that we are talking about, meaning to say we can what? Cross multiply when it is direct. So let's find x. 10 times x. 10x is equal to 1 times 75. So we can divide by 10 by 10. So x will be equal to 7,5. All right. So this is 7,5 centimeters. Okay. 7,5 centimeters like this. And this is 3 centimeters. And this is our x. We took this triangle. Remember, it is the same as this other side. If you wanted to work with this, suppose we said it is an isosceles, but the question was not complete there. Remember, I talked about that. So let's find x. What can we use to find x? It is a right angle triangle. I've talked about this Pythagoras what? Theorem. Again and again and again. Where our hypotenuse is what? The 7,5 squared. So 7,5 squared is equal to A and B are the shorter sides. So you're going to have x squared plus the other shorter side, which is 3. So that's it. We can simplify that one. 7 squared is 56,25 equal to x squared plus 3 squared, which is 9. Subtract 9 both sides of our equation. That's going to be x squared. 56,25 minus 9 is going to give you 47,25. So introduce the square root, just like both sides. Just like what we had before, we're going to have our x, which is 6,87386, and so on and so on. But they told us we are not just supposed to calculate it. Let it be calculated to what? To two decimal places. So to two decimal places, that's going to be 1, 2. This one is not going to change anything. So it's just going to remain as what? 6,87. These ones will be just zeros, zeros, zeros. All right. So that is it. That is it. Remember, we're working with what? Centimeters. So to two decimal places, we've got our answer. We just need to revise, guys. Revision makes everything perfect. The more revision we do, the more we understand, the more understanding you are going to have as an individual. There are some questions that you just need to attempt as an individual without someone, just as an individual where you do not understand. There is a community section. I'm going to talk about that issue of the community section on our YouTube channel that you can actually work with to cater your revisions. To cater your revisions, you've got a question, you can simply take a picture, send it there without taking your time to say, I'm going to go to WhatsApp. Let's all focus on YouTube. That can be the best way of even learning. And some who are coming, they can even trace what you have been posting as an individual. So I'm going to make a video on that one, explaining how we can use our community section to ask questions on YouTube, meaning to say there's no need for us having WhatsApp communication, guys. All right. Anyways, let us see the other part of our question, which is question 5. You are given, you have got 100 meters length of fencing to make. All right, 12 marks, 12 marks, 12 marks. Let's see. What are they trying to say here? This is our total length of fencing that we have, 100 meters. That's our total. Okay. Then they said, you want to make an enclosed pen for your young dog in the backyard. Okay. You can make a circle with circumference 110 meters. From that, you can make a circle which is what? 110 meters in circumference. You have the circumference of a circle there. Or you can make a square with perimeter 100 meters. From the same, you can make what? A square. All right, let's figure out. You can make a square with perimeter of what? 100 meters. Or a rectangle can be made with length, with the width this time of what? 6 meters. Or a rectangle can be what? Can be made. All right. Sorry for that. We can make a rectangle like this with a width of 6 meters. The width, remember a rectangle, there's length and width. So we've got the width 6 meters. 6 meters. We do not have the length. We are not told about the length, but we can figure it out as we do understand that it is 100 meters of length that you are using. So the perimeter does not change. It will be still 100 meters because you are using 100 meter fencing. All right. So that is what you can make from that 100 meter length of fencing. But the question is, which pen gives the dog the most area now? As you have been making this, we are making a pen that it can run up and down, whatever that you have there. Which of the pen that you're creating, that you're making, is going to give us the most area? Where pi is approximately equal to 3.14. Pi being used when we're given what? A circle. That's we can use our pi 3.14. All right. So they are talking about what here, guys? The most area, the biggest, the largest area. Which of these shapes will give us the largest, the biggest area? So what can we do? Just calculate their areas. 12 marks. This is 12 marks question, guys, that we are given there, a 12-mark question. Just calculate the area. You're done. So let's start with a circle. We know the area of a circle is given as what? Pi r squared. That's the area of a circle. We do not have the radius so far. The only thing that we know is what? The circumference. They told us it has a circumference of what? 100 meters. The perimeter. So from that, let us calculate the radius, since we do understand that the perimeter is equal to 2 pi r. Perimeter is there, that's our circumference, C. So 100 is equal to 2 times our pi. They said use pi as what? 3,14 times the radius. So you can calculate the radius from there. So that's 100 is equal to 2 times 3,14. You're going to get something like 6,28. 6,28 times r there, or 6,28 r. So to find r, you can divide by 6,28 both sides, 6,28 both sides. So that was going to give us our r there if we divide. So r is equal to 100 over 6,28, which I'm going to take to two decimal places, guys. I'm just going to round off to two decimal places. Let me fix my calculator to two decimal places. So 100, we said 100 divided by what? 100 over 6.28. That is going to give us to two decimal places. Guys, why is it now? All right, like this, 15,92. So you have to press this SD. You press it again until it gives you the rounded off value. So it's 15,92. 15,92. These are meters. Remember, meters, 100 meters. So our radius is 15,92 meters to what? To two decimal places. If that's our radius, therefore, what is the area? The question is on the area. We needed the radius because of what? The formula there. The formula is saying pi r squared. There is a need for a radius. So now let's calculate our area. So area is equal to pi r squared. Our pi is what? 3,14 times the radius, 15,92 squared, this one. All right, like this. So that was going to give us the area. All right, so you had to work from the circumference, you find the radius, then you calculate the area. To two decimal places, 3,14 times 15, what? 92 squared. It's going to give us 795,82. So that's 795,82 to two decimal places. All right. So the question is, which one is going to give us the most area or the largest area? So it's a comparison. You have to compare your answers. You move on to the square. You do the same thing. You find its area. We were told its perimeter is 100. The perimeter of a square, which is 4s. But we need the area, guys, which is side squared. So from the perimeter, let's calculate what? The length or the side of each part of a rectangle, of a square. We know that they are the same. So perimeter 100 is equal to 4 times s, each side. So divide by 4, as we've got what? A product. We can solve for s. So that was going to give us 25 meters. So s, which is each side of a square, is what? 25, 25, 25, 25, like that. So what is the area? If the side is 25, area is equal to side squared. So area is going to be 25 squared, which is our area is 625 square meters. All right. So we have got the area of what? Of a square. The same thing, we move on to the rectangle. But remember, on a rectangle, they did not give us the length. They gave us the width. Why? They know that you can determine the length. Remember, it was made from a 100-meter fence. So out of the width, remember the width, there's a width this side, there's another width this side. So we're going to say 100 minus what? 6 plus 6. There are two width. So that is going to be 12, 100 minus 12, which is what? 88. So the 88 meters is for the remaining two length. There is this length here, there is this length here. So we must divide it by 2. So it's going to give us 44 meters. So each length is 44. Here we've got 44 meters. Here we've got 44 meters. This is the length that we have. Remember the properties, guys, of your shape. A rectangle. Or if you wanted, you can simply say perimeter of a rectangle is what? 2 into length plus width. Where our perimeter is 100, so it is equal to 2 into what is our length? We do not know. But we know the width is what? Is 6. So you can solve. That's another way that you could have solved for the length. All right, so you can multiply by 2 inside, or you can simply divide by 2. It is up to you. 100 is equal to, you expand your brackets, 2 times L. Remember, I want to solve for the length L. All right, so 2 times L, that's 2L. 2 times 6, that's 12. So subtract 12 or take 12 to the other side. That was going to be 100 minus 12, which is 88, is equal to 2L. Divide by 2, divide by 2. So that's our length. So therefore, our length is what? 44 meters. So as we can see, we have got the same 44 that we calculated. So it is in your hands, guys. All right. Since we have got the length, we can now determine the area. Remember, the question here is about what? It is about the area, not the length, not the perimeter. What? It is about the area. But we were being limited somehow that we must find the length or the side or the radius before determining the area. Now that we've got the length, let's determine our area. Area of a rectangle. Remember, we're dealing with a rectangle here. That's length times width. Length times width, or length times breadth, depending with how you understand it. So that's our length, 44, the longest side, times the width, which is 6. So our area was going to give us 264 square meters at the end of the day. You were going to have 264 square meters. So the question was, it's a question to say, of what you're given, specify which one are you going to say this is the one. So which pen gives the dog the most area? Which one? Is it a circular, which is a circle? Is it a square one? Is it a rectangular one? Which one is going to give us the largest or the most? You check on your answers. You can see that the largest or the biggest value, or the one that we have, which is the greatest value, is what? Is this one on a circle. So therefore the circle gives the most area in that case. All right. So therefore the circle gives the circle pen. All right. The circle pen gives the most area. The most area as we are given on our question, or the largest area, the one which is the largest. All right, so that is how we can play around with our questions. So I want you as an individual to work out as many questions as you can, do revise as many questions as we can, try to figure out how these questions are given, and do as many question papers as you can. All right, 2023 question papers, 2024 question papers, they sum up to everything that you have done in your syllabus. So that is it, guys, from Maths Zone African Motives. Till we meet again.